That's fine. So, to begin today off, I'm Charlie Blair. I teach here at Gateway STEM High School, and I have been a teacher here for 20 years. I've been working with First Robotics since I started teaching here 20 years ago, and in 2005 they started this new thing with this first Vex challenge with building smaller robots, and we started that out the very first year. And a couple years later, they changed the name of FVC to FTC, and that's what you know it as today. And so we've been building robots for that long. We've been through when we had to use Vex kits, and you were only allowed to use the Vex kit of parts. And then it shifted to Tetrix, and you were only allowed to use the Tetrix kit of parts. And as the years went on, they opened it up more and more. And we now kind of call FTC mini FRC because the rules are pretty unrestrained now with what we can do. And so, join us, please. We need more people. You've just missed the introduction, but we've met before. So, our whole mantra is that you don't have to build something that's straight out of a kit of parts, and it opens up a lot more options and possibilities for you. So, we don't use a kit of parts. Now, there's Tetrix, there's GoBuilda, there's AndyMark kits, there's Rev kits, there's Vex kits, and there's pros and cons to using both. Obviously, kit of parts is like, all right, everything's here, we'll just go from this, and there's already laid out holes and stuff, you know, and it can be cheap and it can be simple, but then also, you're limited to what's there, and notice there's cost in both columns, because if you're sticking to kit of parts, then you're like, well, we need to buy more of those parts rather than just like go grab some material and throw something together out of it. So it could be cheaper or it could be more expensive. But if you asked us, okay, like you don't use a kit of parts, then how do you build your robot? I mean, you got to use some parts, right? The electronics, they've got to be. You can't just make that yourself. So if you put it to us and said, what do you use more of? We use more Rev parts than we do anything, but if you looked at a robot, you'd be hard pressed to like look and see Rev construction materials. The things that we use that are Rev, motors, small parts, connectors, fasteners, bearings, things like that. So we use parts from a whole variety of vendors, and you can see some things here, previous robots that we've got displayed here. So, the things that make up a robot, not a secret if you built robots before. You need a skeleton, so structure, some kind of frame, chassis. You need something to make it move. You need electronics. You gotta have tools and machinery, and you gotta have some design. And things that we use instead of using a kit of materials, we use aluminum sheeting, steel sheet sometimes, plastic sheeting. We call that Lexan, which is a brand name, but polycarbonate is the general name for it. We use wood, plywood, use metal extrusions, PVC, 3D printing, and fasteners. And to be specific about some of these. So, sheet metals, if you don't know anything about it, then it's a scary thing to do, because you're like, how do we take this just 2 foot by 2 foot sheet of metal and turn it into something like this? How do you do that? And if you don't have any of those skills, then it's time to branch out and ask for teams that are around to help. We're that team. There might be some others, but we have a full sheet metal shop here, and we can show you how to get to this from just a random piece of metal. You don't need a lot of fancy tools to get here. So we can cut metal with shears. Either a metal sheet shear, which you wouldn't just have that laying around. We have some here. You can also cut it with a pair of hand shears. You can cut it on a bandsaw. You can cut it with a hacksaw. It can be sanded. Aluminum can be cut on a table saw. We sometimes call aluminum metal wood because it's a soft material. And so any blade that'll cut wood typically will cut aluminum, not steel. Don't make that mistake. You can use a miter saw. We have the CNC router that we use. So if you remember the term CNC, You bring in a file and you have it go through and do what it's supposed to do. You can use heat bending for sheet plastics. All the things that we can do for the metal, we can do with the plastics. Drill presses, files, sanders. To put it together, you can use rivet screws. There's another material that we use extensively here, and that's probably because we're an FRC team too, and that's Vhb tape. 3M makes this product, and it's kind of expensive, but we get a roll every year free with our kit of parts from FRC, and so we just have lots of them laying around. But it's super useful because the way 3M shows off this product, they take a chair, put Vhb tape on it, they stick it to a wall, and they say sit in the chair. And you're like, I'm going to sit in a chair that's been taped to a wall? And the answer is yes, it'll hold a 250-pound person. So we use it to stick robot parts together. I mean, we've used it on competition robots extensively to hold things on. For instance, these motors right here, this whole assembly on the top that makes this thing flip, Vhb taped on. It's taped on. It's the only thing that holds this motor assembly and this flapper on. It's very high bond tape. That's what Vhb stands for. So, it's a great product. It works with smooth materials, so metals, plastics, 3D printed parts. It'll stick to wood, it'll stick to painted wood. You can do a lot of different things to lay this stuff out. You can literally use a square and a pencil and draw it out and lay it out that way. Dial calipers are great. If you have the ability to make 3D models, you can make a 3D model, you can print it out on a printer one-to-one. Make sure that when you print it out, it's the size that you wanted it to be. You can spray glue that down onto your material. You can center punch the holes, drill the holes, go to your bandsaw, cut it on the bandsaw, sand it until it's to the lines, and you have good materials. In the beginning, that's how we made parts. This particular chassis right here, no fancy tools involved in making this other than a drill press and just some saws. We didn't use CNC anything, and it looks just like, you're like, wow, is that something you got from Andy Mart? It's similar to something that you might see from them, but it's not complicated. Come on in. You've not missed much. It's just the introduction, but please join us. We're just talking about some options to use other than a kit of materials, and we're talking about sheet goods. And don't be afraid of sheet goods because they can be super useful and helpful. When you use sheet materials, you don't have to worry about, oh, well, the kit only has pieces that are this long. Any length that you want, any size or shape that you want. It's limited to what material you can get your hands on, but you can make sizes of all kinds of things. All right? You can make unibody robots. For instance, this guy right here, it's literally one piece of wood from the floor to the top right here. And so the frame of the robot is very unibodied in that it's not like a bunch of pieces of metal all screwed together. All right? You can make, I'll use the term monocoque or semi-monocoque structures. Anybody know what that means? It's a thin skin that makes structure. Instead of having a frame or skeleton, it's just a thin skin that takes all that load. And using sheet goods, by using folding techniques with a sheet metal brake, you can get those things accomplished. Come on in and join us. So, we might be one of the very few teams in FIRST that embraces wood as a main structure item, but don't discount it. It's great for prototyping because you can use wood to make something quickly. It cuts easily. It cuts a lot more easily than plastics or metals, and you can quickly make something, and if you like it the way it's working, you can then come back and make it out of the plastic that's more expensive or the metal that's harder to cut. The things that we use to cut our woods, we have a laser over here in the corner that we use to cut our materials, but for that we need to have a design first, so we make sure that we have 3D models of the things that we're doing, then we go and cut them out on there. You can cut it with a table saw, miter saw, bandsaw, CNC router. We have a CNC router. I know not a lot of teams do. We have a laser, not a lot of teams do. As one of the teams in the same league as you, please call me and say, we've got a design, can we come and cut it out? It'll take you 50 times longer to drive here than it will to cut it out, because the laser will cut it out in about 2 minutes. Or we can do something on the CNC if it needs to be done that way. Our shop is your shop for those kinds of things. When you're working with wood, we can fasten with wood glue. Wood glue is stronger than some fasteners. If you're a woodworker like me, wood glue is stronger than nails or screws in just overall. So we will prototype pickups. Our very first pickup for this robot right here looked a lot like this, but made out of wood. So we made it quickly out of wood. It did what we wanted, and it took us only a few minutes to cut it out and glue it up. Half hour and we're ready to go, instead of the 14 hours it took to 3D print this part right here. So just another option. You can print, same way with plastics, you can print something out on a piece of paper. You can tape it to the wood, you can center punch all your holes, drill your holes that way to get a good design. I already talked about this. You can make prototypes quickly. And not just prototyping, but our state championship winning robot last year, made out of wood. The sides of the robot, the insides of the robot, all made out of 1/4 inch plywood. So you can definitely use wood in your robot and have it be very successful for you. Some of the things that we do, the kind of wood that we use for our final product is kind of expensive. We use Baltic birch plywood. There's one store in the St. Louis metro area that I know that I can get it from, and that's Rockler. And it's a little expensive, so we prototype out of thin plywood, just from the Home Depot, Lowe's. We call it Luan plywood, and we cut it out of that first. We put it together first, and we probably have 3 or 4 or 5 different sets of these to get everything where we want before we cut it out of stronger, firmer materials. So, 1/4 inch thick material is strong enough for anything we do in FTC. Doesn't have to be 3/8 or 1/2 inch thick. That 1/4 inch material will get you there. So, with your kit of parts, you've got extrusions. The Tetrix has the extrusions with that flower pattern with holes all along it. Rev has their extrusions with all the fasteners that goes with it. Gobilda, same kind of thing. So they're great extrusions, but for us, it's just too constrained in what they have. So we just use various sheet metal extrusions, or various metal extrusions rather. Our arm here is just a 1x1 16th inch wall piece of aluminum. We also use Andy Mark's, they call this a peanut extrusion, because the end of it looks like it's got a peanut there. This hole size is already set up for a 1/4 inch self-tapping screw. So, like, in the middle of our robot, you can't see it, here in the bottom, is one of these with 2/4 inch bolts going this way as a cross piece to go through. You can cut the extrusions bandsaw. Again, as long as they're aluminum, you can cut these with anything that'll cut wood. You can cut it on a table saw, you can cut it on a miter saw, you can cut it on the bandsaw. We actually use a CNC to do precision hole alignment with some of our extrusions that we did for our FRC robot. So you can use that for extrusions. Just because it's aluminum doesn't mean it's constrained to being something that's square. You can get aluminum extrusions that are round. We've used those with success. They don't have to be very heavy. Thin wall is usually fine. If you're going to tap into it, like drill a hole, tap it, and put threads in it yourself, we'll use 1/8 inch wall instead of 16th inch wall, so it's got a little more bite for the threads. But otherwise, thin wall stuff for everything we do here is perfectly fine. Yeah.
Question.
Yes.
For your peanut piece there, you said you put a screw through it into the hole, and it self-taps and then it holds it.
Right.
What happens when you, because I can see, that's where that screw is on the bottom center of that, right? The silver one.
Nope.
Oh.
They're actually all the way on the inside here.
Okay, so my question though is if you take it out and put it in, how many times removing it and putting it back?
That is a great question.
Thank you.
So when we use this, we make sure that we have thread engagements of a 1/2 inch at least. So if you go in a 1/2 inch, once you go in once and back out, the threads are formed and it'll just go the next time. Anything less than that, and you can strip it out because it just doesn't have enough thread engagement, but as long as you go in a 1/2 inch, we've taken this apart and put it back together. Nathan Morrison, our main builder from last year, probably 100 times without any issue. Very early on, we used too short a screw and we stripped it out, and we just didn't use new material. Same material, just put in a longer screw, and that was the rest of the season there. So it's a good question.
So it's threading it for a bolt, and then the bolt has the threads. Okay.
Yeah. So another product that we use extensively, it's so ubiquitous for us that sometimes we don't think about it, but that's the churro from Mark. It's something that we brought over from what we do with FRC, but they are just used for everything. I mean, we have churros all over this robot, and it's what holds the whole thing together. All of our standoffs that hold these plates apart, it's all churros everywhere. So the hole in a churro is the same size as the hole in the peanut extrusion. It's ready for a 1/4-20, so you don't have to drill it. You can either tap it if you don't have a thread forming screw, or if you have thread forming screws, just throw a thread forming screw in there. What we end up doing is we throw this into a vise. We have someone there with a drill and a bit in it, and they just take a thread forming screw, drill it straight down, drill it back out. We don't even use a tap. And then it's ready to go. You can get it in custom colors. So if you're blue, you can get blue or purple or black or green or whatever color. They don't have orange, and I'm disappointed in that. But you can see that didn't stop us. Ours are orange now. We just use spray paint. So it's not very expensive. $9 gets you 3 feet of it in silver, or twice that price for colors. So I just ordered like 30 feet of it for our season. So it's a great material. I can't talk about it enough. PVC is a material that we use in previous seasons pretty extensively. Here's a PVC robot elevator. And the PVC is the main structure. The PVC is what everything's rolling up against. And you can get PVC in various colors. We go through Home Depot because you can get it in blacks and blues and reds and oranges and stuff. Just so happen to be the right color for our team. So you can cut it in all the same ways those other materials can be cut. You can cut it on a bandsaw, table saw. You can use it in a mill, sanders, hand files. You can get it in custom colors, tons of sizes. You mean little bitty to great big. You know, and we've used it with pretty good success. If you've not been to FRC competitions, I've seen whole robots built out of PVC, like their frame, like 2-inch PVC. You know, you can put it together with screws. You can put it together with the PVC glue that once you put it together with PVC glue, it's not coming apart again. Anyone who's done any plumbing, it's not going to come apart anymore. If you want really custom kind of parts, you might not be able to get it in store, but if you want like a 4-way union fitting, you can get that stuff online. So things that aren't used for liquid water plumbing, you can get fancy parts that goes with PVC to make really interesting shapes.
I'm sorry.
Yes.
Question. You have heat bending listed in there?
Yes.
So what do you use for the heat bending, and how does that work?
Well, there's some things that are made for PVC. There's a box that you stick it into, and it heats it up, and you can bend it. We don't have one of those. We use a heat gun.
Okay.
We just slowly turn the PVC with the heat gun back and forth until we can get it to bend to the shape we want, and stop putting heat to it, and it gets hard again very quickly.
When you say box that you can put it in, you're talking about a strip heater?
I I don't know its actual name, but yeah, it's just like a you know, yay big or so, and then you literally just put it in there, close the top over, and it's just heating it
that's
from all
what I'm
sides.
thinking of, okay.
Yeah. I mean, but we just use a heat gun because we don't have one. We make do. So there's a whole other thing talking about 3D printing after this, and so I'm not going to go into too great a detail, but 3D printing can absolutely change your game in what you do. Our entire method for this last year's game would not have been possible without 3D printing. Literally everything to pick up objects on this robot is 3D printed. Everything from here up is 3D printed. And that's not even talking about all the sensor mounts that are 3D printed, the switch mounts that are 3D printed, camera mounts that are 3D printed. Literally the gears that are here are 3D printed. So there are things that you can do if you're like, man, we need some gears, but Rev's going to be 5 days to get them to us. So you go to Rev's website, and you go to the gear, and you go to the models, and you download the model, and you 3D print it. And that's literally what we did. We didn't design gears. These are literally Rev's gears that we just went to their website, downloaded the model, 3D printed it, and with the amount of use that these get, and it's not super hard use, these gears lasted all season long. We never replaced them. What's your question?
You're probably going to go over in the 3D printing workshop, so I'm not going to ask it.
I'm going to ask, and I'll let you know what the...
Like, what kind of infill are you using for the gears?
So they might talk about that, but I'll give you an answer for that. If you 3D print something with 100% infill, it is no stronger than 3D printing it with about 40% infill. They've done studies, and so you can print it twice as fast at 40% infill, and it'll be just as strong as 100%. So for things that we wanted to be strong, we went 40% at the very most. The thing that gives these their strength is the external. We probably could have went 10% on these gears here because it's just run by Servo, and it just does what it needs to do. Things like these parts right here, it's important to think about how you 3D print it. We first 3D printed it in this orientation, which meant it had break lines this way, and we literally broke it off right there. We turned the orientation to print it like this, and that makes the layer lines like this, and then it no longer wanted to break in that direction. So we learned from a mistake, and we went forward from there. You can get a 3D printer pretty cheap. The 3D printer we use is that one sitting right there. We got it for 99 bucks at Micro Center. That literal one right there is what made all the parts on this robot. So it was going around the clock last season. We would make a change in a part because, okay, this works good, move this over. We'd move that over. We'd tell it to print overnight, come back the next day, put the new parts on, and we iterated like that for 2 weeks every day of just move this, move this, move this, move this until it was perfect. So yes, you need to be good at 3D modeling. There's some help out there. They're going to talk about that in the next session. So, fasteners. You're not limited to what comes in that box. With the little 632 fasteners, there's all kinds of things. We use 1/4-20 fasteners on here. We use 1032, 832s. Do not discount rivets. This robot here was riveted together. The base platform here, from here to here. Rivets are quick and easy. Yes, when you put a rivet in, you're like, oh gosh, I can't take it out. No, you can. Just use a drill. It's about the same amount of time as taking it out with a screwdriver. Literally. Just drill it right through. It's a simple aluminum rivet. It'll come right out. So, I talked about Vhb tape earlier. Who was not here when I said Vhb earlier? Because a bunch of you guys showed up. I'll say it again. 3M makes a product. It's Vhb called Very High Bond. And they showcase this by literally taping a chair to the wall and saying sit in it. And it'll hold me, it'll hold you, it'll hold two of us. It's very incredible stuff. So as long as you have a clean surface to a clean surface, relatively smooth surfaces, you glue it on there or you tape it on there, it won't come off. This motor assembly right here that turns these flappers, it's Vhb taped on. There are no screws holding this on. None. We had like 2 failures all season with that, and that's just because, you know, we used it for like hours and hours and hours. It would pop off, we'd taped it back on, and it would last for another 2 to 3 weeks. So, very small amount of contact on this. If you put greater surface area, a strip like this on something, it's not coming off. We've literally VHB taped whole parts on our FRC robot together, and they never come off. So it is a great product to think about using. Recommendation to use hex head fasteners. It's just much better torque that you can get than a Phillips or a flat. So, metric fasteners, it's important to have a good selection of those. A lot of the companies, Rev, I'm not sure about Gobilda, but motors have metric screws. So you gotta go with that from there. So for motion, this is where we get into more of our kit stuff that we use. But we don't buy kit, we just buy the things that we need. Because we gotta have motors, gearbox, servos, sprockets, chains, belt assemblies, axles, etc. There are tons of options out there. There are some better motors out there than the Rev motor with better specs. But for the price and what we get with a Rev Ultra Planetary and the ability to make any kind of speed right out of the box, it's worth it to us. Because then I don't have to like, oh, I'll go and I'll buy this gearbox to do this thing. Instead, we just couple them together with, shift these in and quickly take it apart, put it together. One of our things is like, we speed it up until it fails. So like, we just keep going faster and faster and faster. Okay, it won't work at that speed, go back one. And we can do that quickly with the Ultra Planetaries. We cannot on other things. A big thing that we've learned, the set screw that goes in this guy right here that holds the shaft in, we have to use Loctite on that or it just will come out. It's not about if, it's about when. It'll definitely come out. So we just use a little Loctite glue on it. It doesn't come apart at that point. We use Rev servos, although we're looking for other options because usually a servo fits in the same place a servo will fit from one company to the next. We use Rev servos with some pretty good skill on this last year's robot. We also use their Servo Programmer. So the Rev Smart robot servos, continuous rotation or servo mode. So it can be like I only go from here to here, or continuous rotation. You just plug it into this guy, hit the button, and it's ready to go.
What is it you're finding is a problem with the Rev that you want to replace them?
We're just not getting as much torque or speed. There are other options out there that are faster.
That are legal?
Oh yes.
Okay.
Yes, for sure. At World Championships last year, I was wowed by the different legal servos that other people were using that had more capabilities than this. One of the things that we found was we were using servos to pick up the balls and blocks last year, and it was just like, wow, we got it, but boy, that took forever. And that's how we ended up with the gears to here. So the Rev Servo, I think, is 72 RPM. We literally quadrupled that 4 times from this gear to this gear. If you do the math, that's 288 RPMs. It just so happens to be our team number. Unique coincidence, was not on purpose. But we had to make it faster, and they definitely don't have as much torque as some other options. So I know there's a lot of stuff going down in making servos.
Really quickly on the servo point, if you look in the, I think it's the list of parts you can and can't use, I don't remember what it exactly is called, they have a thing detailing exactly what type of servo you can use, and that includes stuff like quarter scale servos. And those obviously will have quite a bit more torque than the ones that we use.
Right, and now that we've said this, I remembered that basically they say if it'll plug in, you can use it.
Right.
Okay.
So there's a couple specifications, like it might say like you're not allowed to have one over a certain wattage or something like that. And so you just gotta look at that kind of stuff. So these guys right here, the Servo Programmers, it'll work with other kinds of servos, but it's great because you ever like, I want to turn this on, but like, okay, I gotta wait for the programming team to come over, plug it into here, and just make it spin. And you can test it out. We were testing this thing out right here, both motors spinning, so we 2 of these guys at the same time, just plug them both in with a couple batteries in each one, and just go. And we're able to move that guy before my programming team comes in and gets it ready to go. So it really is, for prototyping, a game changer in how we do things.
What do you call that?
This guy right here,
Yeah.
it's the SRS Programmer, Smart Robot Servo Programmer by Rev. I think it's only like 20 bucks or something. Well worth the price to buy a couple of them, because if you got something that's counter-rotating, just plug 2 of them in and go. And then, I mean, you can test it out immediately. One of the products that I like that Rev has for us are these Servo Horns. I mean, about yay big around, but all the holes are threaded. And so for us to come in and put these gears on here, it's just very simple, like make the hole pattern, bolt it on, and it's ready to go. And so how do you get it to connect? You just slap the horn on there. And so it's been our go-to for getting those things going nicely. And there's so many different hole patterns on here for you to do things with. So, making motion happen, Rev has their plastic sprockets and their plastic pulleys. We've used both. Really, we use more of the sprocket and chain than we do the pulleys. But don't think that, oh, it's a chain, it's going to eat that plastic thing. This is like some nylon plastic. We've never had a Rev plastic sprocket fail on us. We've never had one fail. They work. They're lightweight, they're simple and easy, and I've never had the shaft spin through, so I mean, well, we go with them, because you can buy a kit of those much cheaper than you can buying the metal ones. So, they also have their plastic gears. I don't know if I'm ever going to buy a plastic gear from them anymore, because we can just 3D print them. I wouldn't 3D print the sprockets, but the gears, there's enough tooth contact here that it just works. If you find that you're not getting enough contact, and you go to 3D print one of these in your slicing software, just make it taller. You don't have to change the model at all. Just tell it to be taller, and it'll just make it taller, and now you've got more engagement tooth to tooth. And so, yes?
What do you mean just make it taller? Like,
So, when you go into a slicing software for a 3D printer, you can tell it, do I want to make it bigger on the X, the Y, or the Z axis? I just make the Z axis taller. It'll just stretch it. But because it is linear in this direction, it just makes it taller and doesn't change any other properties to it. And then you have longer engagement tooth to tooth to make that work for you. So a lot of teams struggle with, okay, so I'm using sprockets. How do I make sure that like I can get this thing to fit? And like, do I have to worry about a half link and stuff? We used to buy half links so that we could get chains to work real nicely. We don't buy half links anymore. Instead, we just make sure the center to center distance is exactly 1 for links. How do we do that? Rev has some really great resources on their website. It's not hard math. You just punch in the numbers. There are, for each sprocket you use, there's a different coefficient. You just say this sprocket to this sprocket, and I want it to be about 5 inches apart, and it'll be like, okay, actually 4.92. Use that distance in your 3D model, and when you go to put a chain on there, it'll be exactly the right length. So we don't even use master links most of the time. We make the chain the exact length we need, we slide it on, and we're done. It has changed the way we do business with chains. We don't have chain slip or chains falling off anymore. We rarely use master links. We definitely don't use half links if we can avoid them. We have them in the box, but we just don't need them anymore.
You're printing the chain?
No.
No.
Did I say that?
Well, I got lost at the end. You said you measure it, and then when you create the chain, you make it the exact length.
So, like, when you calculate it, it'll tell you this needs this many links. It'll always be an even number, not an odd number. And so we count. We're like, okay, 48 links, put it together, and it just fits.
Okay.
The chain's not too tight, the chain's not too loose.
Okay.
And so you just calculate it in the stuff that they'll show you how to calculate it, and it's easy. Honestly, we do that, and then I just put it in an Excel document so I can just punch it in and it spits out a number real quick. And I've taught my students to do it the same thing. So this right here is how we make things work without having a kit of parts. Because you're like, there's all this stuff, but how do we make motion happen? Because it's not moving, it's not doing anything. And so we use the Rev bearings, we use the Rev 5mm axles, and that's how we do business. So, like, when we have holes for things, we make sure the holes are 12mm holes for the 12mm bearings. And then they just press right in. I recommend that you get yourself a 12mm step drill. Rev sells them. This is not one, this is just one I got off of Amazon. But it's just, its biggest size is 12mm, so you can get the hole to close to the right size, and then you just go through and bore it out with the 12mm, the bearing will push right in. And that's how we make motion happen for us, is we use these bearings. The bearings are just round on the inside, but they have these little plastic bearing inserts that have 5mm hex holes in them. Just snap that into one of those, and it just works. It's a dream for us. I mean, we use them on everything that moves for us, except for servos. Yes?
So that's a rev part?
Yes.
It comes with the little hex inserts?
So, you buy them separately, but the hex inserts cost nothing. It's just like a bag of 20 of them for like a couple bucks. The bearings are a little more expensive, but I mean, they're not very expensive. And so, we use them for everything. So speaking of the 5mm shafts here, you can get yourself a 5mm hex broach. A broach is an object that makes a hole that's not round. It can make square holes, hex holes, depends on what you have. And so it's a very expensive tool. It's about $200. Buy it once and you won't need to buy another one unless someone drops it and breaks it. But we'll make parts like our 3D printed parts, and it'll have that 3D printed hex hole, and it won't be perfect. And then we go over to the arbor press, and we just use the broach, and we broach it through, and then the hole is perfectly true in 5mm, and you don't have a hard time sliding the shaft in at all. So it really works great. In fact, our wheels that we have on our robot, they have custom shafts, or custom hubs, because we didn't want to use the weird little hubs that you have to like screw in, because we've had issues with those in the past. So we had custom aluminum ones CNC made for us, and they came to us with just round holes in the middle, because the guy's like, you have a broach, right? Like, yes. So they brought them to us, we went over, used the broach, we broached the aluminum to a 5mm hole, and now the shafts just slide right in. So there's another product here that Rev sells, and this is the 5mm to 1/2 inch. So the outside of it is 1/2 inch hex, because sometimes there's products that you can't get in the shape that's what you need, but you can get it in a 1/2 inch hex. All right? You can take the 5mm, and the inside hole is 5mm, slide it right through. And now you can drive it with 5mm, meanwhile the object on the outside is 1/2 inch. They call that the Ultra Hex Shaft. So we just have a bunch of it so that we just cut off the length we need. Sometimes we're like, we want to use these wheels, but the wheels have a 1/2 inch hex. So we use this right here, go from 1/2 inch hex to 5mm hex. And that gets us what we need for that.
Really quickly, and that can be helpful for not just like driving stuff off chains, but if you wanted to direct drive, say for example, there's a wheel that Vex sells, but they only sell their hubs in like 1/2 inch hex. And 1/2 inch hex is just better to support robots on anyway in terms of axles. So what we'll do is, if you wanted to direct drive that, you would put the 1/2 inch
Pass it around.
hex
Don't drop it on the floor.
Through the shaft of the mechanism.
Do not drop.
And the direct drive from like a Rev motor, which has that 5mm hex shaft. Sorry, but
That's good. We all have our own opinions on wheels. There's tons and tons of things you can get out there. We're not sold on any one system of wheels. We use Andy Mark's, these are called sushi rollers right here, but they're just 1 inch diameter, 1 inch tall wheels. We use those for picking up. And that's really their stealth wheel pattern. It's just that these are really small. Andy Mark's stealth wheels, they're pretty great. They come in every kind of hub that you want. You want a 1/2 inch hex? Yes. You want 5mm hex? Yes. You want round? They've got that for you. They come in 2 inch, 3 inch, 4 inch. I think they can get up to 6-inch. They come in a variety of durometers. Durometer means how grippy they are, which means that they're in different colors. The green ones are the grippiest at about 30, the orange is at 40, and it goes up from there. So we use those on a lot of things. For drive wheels, everybody is in the mechanism game now because mechanism is where it's at. So what's the best mechanism wheel for you? They're all great options now. It depends on how big you want it to be. The Rev mechanism, which are these ones right here, they're only about 3 inches in diameter. They're not that big. And for this last year's game, we wanted to be able to drive over those 1-inch bars. So we went with a bigger wheel. We went with the Go Builda. They're just as good as the other kinds. It's just that it was bigger around. So some are more expensive than others. I think that there's a game changer coming out. Rev, in October, is coming out with their slim mechanism and a 4-inch wheel. Now, back in the day, Rev was the very first Rev. Andy Mark. I'm sorry, I said the wrong thing. Andy Mark. Back in the day, Andy Mark is the company that innovated bringing mechanism wheels to Vhb Robotics. They were the ones that came out with the 8-inch mechanism, very first thing. All right? And they're up in their game with this new wheel because the rollers are actually ball bearing driven. So all the rollers are on ball bearings, so it spins smoother, and they're not quite as wide. So I'm definitely going to go buy a set of those for my team to check out and try out as soon as they come out in October. I'm on the mailing list of mail me when they're available. They're not super expensive either. So electronics, we all have to use some Rev products for that. You either use a phone, an expansion hub, or the control hub if you can get one. But some things that we use that help us out is the Rev power distribution module, plugs into the battery, and then everything plugs out from there. We use these guys extensively. We use the XT30 power distribution little plugs here. They're really simple to solder, even if you're not great at soldering. They're not hard to solder at all. We use a little bit of heat shrink, solder, heat shrink it down, and it's good to go. For your servos that you use, this product right here will deliver more power to your servo than if you're plugging it directly into your expansion hub. It gets power directly from the battery instead of taking power through the expansion hub. So it's a more direct route. The only difference is it's just getting a signal. So the expansion hub goes to here, it says, hey, turn on, and then this says, take power from here directly out. It's just a relay module. But we use that for all of our servos. So it's kind of nice. Yes. Question, I heard it.
Go ahead.
To go back to the power distribution stuff, that's going to be really helpful. I remember I did a lot of volunteering, especially on the back end side of some stuff. A lot of inspecting, a lot of on the field play, saw a lot of brownouts from teams using servos too heavily. Partially because they were going through the expansion hub or through that control hub. Going through the power distribution stuff, going through that servo module will help increase your ability to have power to that servo, but also prevent your controllers from browning out. Because once you have like a lot of torque on those servos, you're going to be drawing a lot of battery, a lot of current from the battery, and that's going to, you want to have it direct to the battery instead of, or as direct as possible instead of going through that brain system of your robot as well.
Okay, I think we definitely suffer from some of that.
Well, question, go.
Well, the question I had is, we use both the control hub and the expansion hub connected to it just because we had to drive, I think, 6 DC motors. Do you have both of those in your robot as well?
Sure. We use the control hub and the expansion hub.
Okay.
So yes, you have 4 motors off each one, but then we still use the servo power module because it doesn't draw that extreme power from the hubs here. And it's that thing right there where you've got 8 servos going for all these small little mechanisms. You're like, it's not doing much, but 8 of them at a time, it's going to really draw down the current in those hubs, and it can cause you to have that little low power,
Yeah.
and it can really destroy a match. Yes.
So does that servo like module speak to like the controller expansion hub and also separately connect to the battery, or?
So the way it works is it plugs into the battery and it just says, I have juice for when you need it. One side is an input from the expansion hub, the other side is output to the motors. You don't have to have, well, I mean, yeah, you're already going to have these Rev products, but this could work with any kind of a thing. It doesn't have to be with Rev, even though it's made by Rev. It's just a relay. It's just a thing that says, when I hear word on this line right here, I'm going to send something out on this line right here. That's all it does.
So then one more is the power one, like, does the battery go straight to that and then that goes to literally everything else?
Battery
or?
to switch to here, and then this to giving power here, this giving power here, this giving power here,
Okay.
this giving power to your light system. Is it on? The battery? I don't know what the switch is.
Yeah, there we go.
Lights. The battery, so that just powers up anything. And it's got 1, 2, 3, 4, 5, 6 places to plug in. We've never needed more than one, but we have used 5 out of 6 before. How many are we using on this one? It's on here somewhere. Anyway,
I think it's 5 out of 6.
yeah, probably 5 out of 6 on this one.
I have one more question.
Yes, please.
We had a DC motor we were using to power an arm, and we had it. I can't remember the 2 modes, but there's a
Brake and coast?
position.
Brake mode.
I'm imagining that's a huge drain if it's having to hold that position against the arm.
So that is a great question, and we could talk about that at length because we have the same kind of thing here: arm, hold to position, and it can be a lot. That's where your say the letters for me.
PID.
That's where your PID loop comes in, your proportional integral derivative, and so you tune that in to make it work for you. But also, if you can give it a counterweight, so that the motor's not trying to hold it right here all by itself, that can really help. Counterweight can be in the form of an actual weight. It could be a rubber band. It could be surgical tubing that's pulling it back down. Something that, at this point right here, I've got a great moment arm, and the moment arm says, I want to go down. There's no power applied. You see it staying in place? So we have this long arm, this short thing, but this weighs 6 pounds. So we went from 4 pounds to 6 pounds. We kept going up in weight until this would stay on its own, and now it's just neutrally buoyant. It just stays wherever you put it. And so when we tell it to go to position, it says, I'll go to position, and then I'll hold it there, but it's not killing the motor to do so. You'll burn up a motor. You absolutely will over time.
Yeah. Okay. Thank you.
Some things that we use, we make our own PWM cables. Get good at this. Buy the PWM male and females, buy some of the little plastic guys, get the tiny little crimper for those, and start learning to make them. It'll change your wiring. Instead of having a rat's nest where you don't need a 24-inch PWM cable, you need a 6-inch one, make a 6-inch cable. And then you don't have to worry about all that extra stuff. You can have a roll of PWM wire, and you can make the cables that you need. I teach some people to do this, and then they just do that. And I'll be honest with you, girls are always better at it than boys. They just have more attention to detail with making those things, and so I teach some of them, and then they're the wiring people to make the little wires like this. We also use Anderson Power products for extensions of things. So these are a little bit easier to put together than the XT30 connectors because they're crimp connectors rather than solder connectors, but they do the job for us. So they're kind of nice. PWM crimp tool. That's the little guy that makes those little PWM cables. We use a chain breaking tool. This allows us to take a chain apart and put it back together without a master link. There's this one. Rev sells one that looks different, does the same thing. Ours is actually from a company called Dark Soul Racing because, I don't know, but that's where we got it from. So, great product to have. We talked about broaches. We have the little 5mm broach. I thought I had a big one up here too, but I guess I don't. That's okay. We have a 1/2-inch hex broach that we also use to make 1/2-inch hex holes. They're great to have around. Your step drills to get to that 12mm hole, or just to get bigger holes in general. If you want to make a hole that's this big, bigger, how do you easily do that? Your twist drill bits aren't going to get the job done. Hole saw is going to get the job done because you don't have a center anymore. How do you make that hole bigger? A step drill is the right answer for that. Use a step drill and it'll just step it up till you get the size you need. Get yourself a good set of metric and standard drivers with handles instead of just Allens. You'll speed your kids up. It'll speed you up. You'll be faster. T-handles. We're in a unique situation, I think, that a lot of people are not in. We have a lot of things that you don't have, but if you want, you can have it whenever you want. Just come here. I will not say no to you. So we have a laser over here that'll cut anything from 2 feet by 1.5 feet in sheet materials. It'll cut woods, it'll cut plastics, it'll engrave. We make vinyl team numbers. If you're like, hey, can you help us make some vinyl adhesive numbers for our robot? Yeah, sure. I'll be like, here, go to Amazon and buy this stuff. Come over, we'll take us a few minutes. We'll get you done. We have a brand new 4 foot by 4 foot CNC router over there. It hasn't done anything yet. I'm just getting it powered up this week. But once I get it going good, I'll be happy to have you use it if you come over. Drill presses, bandsaws. You should have drill presses and bandsaws. Come on in. Table saws, miter saws. Yes, we have a lathe, and we use it for a lot of things. We use it to center drill stuff, to make holes in things bigger. We use it for cutoffs and things like that. Disc sanders, 3D printers. We have a full sheet metal shop, so if you're like wanting to make something out of sheet metal, we have the skills to help you do those things. To make things that have nice bends in them here and another nice bend in here, so that it makes a structure just like this. So for much less than the price that you buy one of those towel runners, you can make something that looks just like a towel runner. So we have access to all that stuff here and the knowledge how to use it. If you want, just call us and we'll be happy to set up some time to work with you. We're here every week, so yeah. When were we supposed to be done? 5 minutes ago?
5 minutes ago, yeah.
5 minutes ago. Well, we got started late. So that's kind of it. I can walk you around and show you anything you want to see in the shop here. Or if you want my contact information, that's also right here. And